Alright, over here I'm going to do the partial fraction part 2, which is saying about the improper fractions. So over here, if you see this equation, you should know it is improper fraction, even though you see the x cubed on the numerator, but then in the denominator you might see something like x squared x. It seems like the power actually is smaller than the numerator for x, but then you shouldn't see this way, because you always need to expand it and then see what is the highest power in the of x in the denominator compared to the highest power of x in the numerator. So if both numerator and denominator have the same power of x, that means this one we will use the improper fraction methods to do it. Of course, if the numerator is highest, definitely we will use the improper fraction method as well. So this one is improper fraction. Alright, so in order to do the improper fraction, normally we will do this few steps. The first step over here, we will actually expand the denominator. Alright, then the second step, we will do the long division. We will do the long divisions to actually like make the highest power of numerator become smaller. Alright, so and then the last step is we will do the partial fraction part. Alright, so normally when you do the last step of partial fraction, you will get 1 plus something or 2 plus something, depending on the question. So we will only take the fraction to solve it. We will not take the constant value. Alright, so anyways, okay, let's show you how to do this one. Alright, so the first thing is I will expand the denominator. I will do the first step. So expand the denominator. So this is what I will get. So if I expand, I actually getting x cubed plus x squared. Right, then I will do the long division. So I hope you still remember how to do long division. So basically is numerator divided by denominator, right? So numerator I write inside divided by x cubed plus x squared. Alright, so if you divide this one, because we want to eliminate the highest power of x, which is x cubed here. So if I put 1 here, because 1 multiply x cubed, you get x cubed. 1 multiply x squared, you plus x squared. Alright, in the long division over here, you should know here you have an invisible minus here. So when x cubed minus x cubed, you actually get 0. So then you will left over like 3 minus x squared. So I write 3 minus x squared. Right, this one will be your remainder. Alright, so therefore I know this one, if after I use the long divisions, mean I can write in this way. This is 1 plus remainder, which is 3 minus x squared, over the divisor here, which is x cubed plus x squared. Alright, if you do not believe this answer, you can try to make the 1 become the same denominator and then you plus again. You definitely will get back the first one. Alright, then this is what I means by after you're doing long division, you get 1 plus a fraction. So normally the partial fraction we will do only focus on this part. Alright, so then the next step is I want to expand this one using the partial fraction way. So okay, let me just erase the long division. Alright, so I will just maybe I do over here. Alright, so this one is 3 minus x squared. Of course, the denominator I will use back I will factorize back the x squared. So this is x squared, x plus 1. Alright, so this one is x squared. So some student might like confuse, because you have x squared, like which method you need to use, because actually we have like another three more methods over here, right? So okay, what I will do over here is I will do something like a over x squared plus, because this is x squared, right? So I will do b over x. Still remember the repeat methods. Alright, so I will plus c over x plus 1. Yes, some students might remember that if you see the x squared, can you actually write something like ax plus b over x squared and then plus c over x plus 1. Yeah, actually these two methods, they are totally the same one. Alright, so you can use either of You can use either one, you should get the same answer. Definitely the first one, actually in this case this is only x squared, right? The first one actually is a lot easier. Not say a lot easier, it's slightly easier. Okay, so why do I say both of them are the same? Is like you're trying to imagine if I have this one ax plus b, right? If I separate them, this ax over x squared plus b over x squared, isn't it? So x and x I simplified. This is a over x plus b over x squared, right? So you can see, so if I a and b, because a and b is just a constant value we do not know, if I swap a and b, I actually getting back the exactly the same thing, a over x, b over x squared. Right, so definitely depend which method you like, but normally in this case we only have x squared. If we have something like x squared plus 2, then no choice that you have to use the x plus b. But in this case you only have x squared, so I will just use the first one because it seems easier. Alright, so therefore I will expand it like what I do in the last video. I will multiply x squared x plus 1 for every single one. So you just imagine if you multiply the denominator for the whole thing here, this one you're left 3 minus x squared. So over here if you multiply x squared and x squared, you can simplify, right? So you should left a x plus 1 plus b, this one x and x you simplify, you still have one more x, isn't it? So you should have a x and x plus 1. Alright, then plus c, you imagine x plus 1 and x plus 1 you cut, so you will still left a c x squared, isn't it? Alright, then you will use some values of, you will give yourself some value of x in order to make this equation very easy to solve. So the easiest one, I guess I will choose x equals to 0 first, because x equals to 0, the c will become 0, the b here will become 0 also, because b times 0, that everything you get 0, so you straight away you are actually getting 3 minus 0, you left a 3 here, equals to 0 plus 1 is 1, so a equals to 3. Straight away you get an a. Alright, then I want to make the x plus 1 become 0, so I will assume my x equals to negative 1. Alright, so if my x equals to negative 1, this the whole thing becomes 0, so I only left the c, negative 1 squared is just 1. So c, this one 3 minus 1, so it's 2. 2 equals to c, because negative 1 squared is just 1, alright? Alright, then I will choose, since I have a and b already, I can put any value of x, I just use 1, because 1 is an easier number to solve. 3 minus 1, I get 2. Alright, a I just got is 3, 1 plus 1 is 2, plus b times 1 is just b, 1 plus 1 is 2b, so plus 2b, plus c is 2, 2 times 1 is 2, so I will just minus 2 for both sides, so 2b will equals to negative 6, so b will equals to negative 3. Right, after I got the a, b and c, so I just plug into the equation, so I just solve this thing, so into this pattern, right? So my a is 3, right? So I'm going to plug in the 3 over x squared. My b is negative 3, right? So I'm going to plug in my negative 3, so I'll write minus 3 over x. And c is 2, so plus 2 over x plus 1. Alright, this is how we do the improper fraction part. Yeah, actually it's still the same as the previous method, but normally the improper fraction, you realize the equation is improper fraction, normally you expand the denominator first, you expand the denominator, alright, and then you use the long division to get something like 1 plus something. Alright, then the fraction over here, what you need to do is use back the partial fraction methods to actually separate them. Alright, if you see the denominator is only x squared, I would recommend you to use this method. So just repeat, this is x squared, so you repeat again, you write x. Or you prefer to use x plus b, yeah, you can do so. Alright, I guess that's all for this part 2 video. I hope this video can help you understand how to solve the improper fraction part. Alright, so I'm going to see you guys in the next video. If you still cannot understand this video, please let me know in the comment below. If you like this video, I hope you can subscribe my channel. Alright, see you guys in the next video. Bye bye.